Next question is, by method of induction, prove that 1 into 2 plus 2 into 3 plus 3 into 4 plus n plus 1 is equal to n by 3 n plus 1 n plus 2. First step, combination. Pn 1 into 2, 2 into 3, 3 into 4, n plus 1, n by 3, n plus 1, n plus 2. To prove Pn is true for n is equal to 1, therefore put n is equal to 1 in LHS. Therefore LHS is equal to n plus 1. A is 1, so 1 plus 1. Now 1 plus 1 is 2, 2 into 1 is 2. RHS n by 3, n plus 1, n plus 2. Put n is equal to 1, therefore 1 by 3, 1 plus 1, 1 plus 2. Now here this is 3 and this 3 gets cancelled, here remains only 1 plus 1, that is 2. Now therefore LHS is equal to RHS, therefore P1 is true. Step 2. Assumption. Suppose Pn is true for n is equal to k. Therefore Pk 1 into 2, 2 into 3, 3 into 4 plus k plus 1 k by 3 k plus 1 k plus 2. Step 2, assumption. Suppose Pn is true for n is equal to k. That means in this statement where there is n, write k. Third step. Step 3, succession. Step 3, succession. Look at these terms. Now this is the term when we add here 1. This is the term when we add 1 here. In this way, the next term is we have by adding 1 here and adding 1 here. That means that terms becomes k plus 1 and k plus 2. Every next term 4 we have by adding 1 here, 3 we have by adding 1 here. That means next term is by adding 1 in every term. So here is k plus 1 and here is k plus 1 plus 1, that is k plus 2. Now here is sum, therefore we have to add this term, add this term. We add it at LHS, therefore we also add to RHS. Therefore right here add this term to both sides. To both sides. Therefore 1 into 2 plus 2 into 3 plus 3 into 4 plus plus k plus 1 and add. That means here there is product. In between these two terms, there is product. Here also there is product in between these two terms. Now we add k plus 1, k plus 2. We add it at LHS, therefore addition at RHS. K by 3, k plus 1, k plus 2, add k plus 1, k plus 2. Next step is k by 3, k plus 1, k plus 2. Now here is denominator 3. So for this term, we take denominator 1 for solving purpose and take cross product k plus 1, k plus 2, cross product k plus 1, k plus 2 plus 3 k plus 1, k plus 2. At the denominator, product is 3. If we see then here there are two terms. This is one term and this is one term and there is sum. So we take common terms. We take common k plus 1, k plus 2. Remaining terms, k here remains k plus 1, k plus 2. Common here remains k plus 3 divided by 3. First term as it is. Add here, replace k by k plus 1. But here is k plus 2. So here plus 1. Split this k as k plus 1. Here is 3. So plus 2 is there. Divided by 3. First term as it is. Split k plus 1. Here is 2, therefore plus 1. Split k plus 1. Here is 3, so plus 2. K plus 2 is here, k plus 3 is here. And now look at this step. Where there is n, there is k plus 1. N, k plus 1. N, k plus 1 divided by 3. After splitting, look at this step. Where there is n, there is k plus 1. Therefore, we say that pk plus 1 is true. Therefore, we say that pk plus 1 is true. Step 4. Induction. Therefore, we say that by method of induction, Pn is true for all n belongs to n. It is true for 1, true for k plus 1, so that it is true for all n belongs to n. And important steps are foundation, assumption, succession and induction. And here is step 4, induction. By method of induction, we say that Pn is true for all n belongs to n.